This is Algebra 2, Lesson 9.3, and in this lesson we're going to talk about outliers. An outlier is a data value that is significantly different from the rest of the data. Now, the word significantly isn't really measurable, so we are going to define how far it has to be to really matter and be a true outlier. So we might talk about, if our data goes from 1 to 10. If we have a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we also have one data point of 50. That obviously sounds like an outlier, because if all our data is in the first 10 and we have something way up in the 50s, it's pretty far away. But what makes something significantly far away? If that value was 20, would it be far enough away? If it was 15, where's that magical line? And that's what we call the fences. The fences are the boundaries that determine if a data is far enough away. And we define that to be more than 1.5 interquartile ranges from the interquartile range. And I'm going to put that into a formula. So the lower fence would be any data value less than the first quartile minus 1.5 times the third quartile minus the first quartile. And then the upper fence would be any data value greater than the third quartile plus 1.5, again, times the interquartile range, Q3 minus Q1. So any data value lower than the lower fence or higher than the upper fence would be an outlier. Symmetric data would be when there really isn't an outlier, or there might be outliers on both sides. You'll have a pretty even distribution. There might be outliers on either side, or there might not be, but it's going to be pretty even on both sides. Whereas skewed then would be where you'd have a lot of your data on one side and you'd have some outliers over here. Wherever your outliers are, that's where it's going to be skewed. So this one that I just drew is skewed to the right because my outliers are on the right-hand side of the graph. I have upper outliers. I could be skewed the opposite direction and have a longer tail on the left. That's going to be a lot of lower outliers or very few points on the lower edge of the graph. That would be skewed left. You can do this with box plots and with histograms, with any kind of data, but anytime you have a lot of lower outliers or very few low points, that's skewed left, and then the reverse would be skewed right. So with that, we're going to take some data down here. We have data about the points scored by Chicago Bulls players in the 97-98 season, and we're going to find our 5-number summary and then calculate our outliers. So if we're looking at this, it looks to me like Michael Jordan is obviously an outlier. He scored more than double the second place player. So my 5-number summary, I have my minimum value down here and my maximum value up here. And then if we cross off and we find our center, we have our median right there. We are going to cross off again to find our quartiles. But remember, we match up this value with the maximum. We don't match up the median with the maximum when we go back to get our upper quartile. And then same thing, we're going to match the 376 with the minimum. And there. So we have our lower quartile. We have our 5-number summary, 167, 288, 416, 841, and 2357. Outliers. So we're going to calculate our fences using the formulas up above. Our lower fence would be Q1 minus 1.5 times the third quartile minus the first quartile. So that is going to be 288 minus 1.5 times the third quartile minus the first quartile. And let's see if I can get my calculator up. So 288 minus 1.5 times 841 minus 288. I got an extra parentheses in there, but it's not going to make a difference. So that is negative 541.5. Now, obviously, no one scores negative points in a basketball game. So we don't have any values lower than negative 541.5, so we have no lower outliers. We're going to do our upper fence calculation. That'll be Q3 plus 1.5 times the interquartile range. So we'll have 841 for our third quartile plus 1.5 times 841 minus 288. So we're going to put that one into the calculator, and we'll make this say 841 plus, we really don't need that, 1,670.5. So Michael Jordan was definitely an outlier with 2,357 points, but he would have been an outlier with 1,671 points. 1,670 would have been the highest value to not be an outlier. And that's what the fence does. It tells us what value is high enough that anything lower than that value is a standard data point. It's not significantly different from the rest, or what value is officially an outlier. So the last portion of this question was to draw a modified box plot. A modified box plot looks very similar to a standard box plot, but we add points to signify outliers. So I'm going to go with 0, 500. I'm going to go by 500 on my scale here. And we're going to add a point for the minimum. So 167 would be about here. We're going to add a line to signify our lower quartile. 288 would be kind of in the middle of 0 and 500. Another line for our median, 416, just under 500. Another line for our third quartile, 841, kind of in the middle there. And we're going to do a dot for our maximum, 2,357, way over here. Now for a modified box plot, we're still going to draw the box for our interquartile range. We're going to add this line to our minimum, add that whisker, but I'm not going to draw my whisker to go all the way to my maximum. Since it's an outlier, I'm actually going to stop my line at the highest data value that's not an outlier. So 984 would be right about here. So I'm going to draw my line there, but I'm going to keep this dot here to show that there is an outlier way out. We have some skewed right data with these Bulls players. So that's it for the notes. Good luck on the exercises, and let me know if you have any questions.